All right, there we go. Traffic lights, yes. Will we ever forget the traffic lights? Tinkercad is a pretty solid tool for this stuff. I mean, there's still the experience of like being in person and actually, you know, touching the stuff and physically putting chips into boards and that kind of stuff. But if you got to be online, Tinkercad's a pretty good next best thing. And for frying things, definitely. So yeah, we're gonna talk about the midterm today. All right, let me get some stuff up here, and let me pull up the midterm. So I got grades and feedback posted last night. So midterm was pretty good. Number of cases, no issues. Got resistor hot, yeah. Tinkercad, you just get the little explosion symbol, right? Saying like, you know, something wrong with the chip. All right, let me pull up the section A. Grab my notes. All right, so question one was basic class construction, right? Just putting together the parts and pieces and writing a few methods. All right, so question one, not a whole lot to worry about. So class name vector, 3 private integers. So class vector. Private int xyz. And then a pair of constructors. So the first constructor takes 3 arguments. No, you can't. Thank you. So first constructor takes 3 arguments. So what's your constructor? It's public, and then the name of the class. And, you know, one way to do this, A, B, C. X equals A, Y equals B, Z equals C. All right, so that's a standard constructor. You also have the option of doing something like this, which makes a little more sense than ABC. But saying X equals X doesn't do anything, right? So what we want to do is set this object's X equal to X. So this is really the main place you're going to use this. So like that. And then a constructor with a single argument, so right, which sets all three of them equal to A. And a few people interpreted this as have one of these for X, one of them for Y, one of them for Z, and so that's okay. But this, the idea here is you want to make a vector where everything's equal to 1 or something, or 0, and so you can, instead of having to pass 3 numbers that are the same, you can just pass one number. And it's the idea that, there's a signature for methods and constructors. So both of these are called vector, but they're different constructors because they have different argument lists. Public methods. So main thing that people lost points on here, a method called sum that returns the sum of these. This is really just, public int is the return type, sum, no arguments. Right? So this is how we do objects. You could make a method called sum that you pass x, y, z to, and it returns x plus y plus z. That's not really what we're after here, right? If we have an object of type vector called v, we can just say v.sum. And this method will reach inside v in this case and find v's x, y, and z and add them together. So your methods, which were sum and reset and ordered, don't take any arguments, right? Which is an important part. So reset just set everything to 0, so doesn't return anything. Public void reset x equals y equals z equals 0. And then ordered, so the only thing that people kind of consistently lost points on here was the logic. So ordered x bigger than y bigger than z. Right, so some people did this. That will give you a compile error, and the error will be method may not always return a value, because if this is true, you're telling it to return true, but what should it do if that's not true? Well, it falls off the end of the earth and you haven't returned anything. So you can patch this up by saying return false. So that'll work, that'll get you full credit, but there's other things you could do also. Right, this will also work, but this is needless. So this is a Boolean. It has a true or false value, and this says, calculate the value of this Boolean expression, and if that is true, then do this. So this actually does the same thing as this. And you could also just do this. Right, one line, which says decide whether or not this condition is true and return the truth of that statement as the value of the function. And so your whole ordered method could just be a one statement return. So long as it would work, right, you got credit for it. But in some cases, I pointed out some suggestions for other ways that you could do this, just to sort of keep in mind going down the road. I'd never want people to get bogged down with trying to make, the shortest code or the most elegant code or something like that. But I want you to see these other things and be aware of them and just sort of keep them in mind as you go. All right, so number 2 was adding accessors and mutators. So the whole idea of this is, you've got a class. So let's make our public class Nixon. And you've got integers, secret tape, and secret tape 2. And we want to use information hiding, so we want to make these private. Let's see, problem didn't explicitly say to return false otherwise. But your method declaration says it returns a Boolean, and if you don't specify a return value in all cases, it won't even compile. So Boolean means true or false. So you want to make these things private so that outside access is denied to these, but you still want to be able to read and write these, presumably in some controlled way, although I didn't specify a control here. So you make accessors and mutators. So what's an accessor? It's a public method. Since these are ints, let's make an int. And the standard way to name these things is get with a lowercase g, and then the name of your camel-cased variable, but obey the camel case of this method name, so make the first letter uppercase. And then no arguments. And just return that value. Right? So that's a totally standard way of making an accessor. And Eclipse will actually make these for you. If you need access to something and it's hidden, it will say, click here to create accessors and mutators. And it will write this code for you exactly like this. So you can do the same thing for, secret tape 2. So those are your accessors, and then your mutators don't have to return anything, and they're called set secret tape. And you can call this whatever you want, but again, the standard way that you would write this would be to call it the same thing as the variable you're trying to mutate. And then here's where we can use the this keyword to good effect. This dot secret tape equals secret tape. But if you don't like this, you can call this x and just say secret tape equals x. And then do the same thing for secret tape 2. And you didn't need both of those. You only needed to be able to get secret tape 2 and set secret tape. So if you had those, you were good. But then you can use these inside. Grab my mouse. You can use these inside this code here. And instead of saying x equals, secret tape 2, you could say x equals president.get secret tape 2 paren. And instead of setting president secret tape equal to 2 times x, you would say president.set secret tape parentheses 2 times x. And so now these things are happening through methods instead of just manipulating these fields directly. And that's the whole point of an accessor and a mutator, is instead of having direct access to the fields, you have access to methods. And then we could, put some things in here, like say, if secret tape is smaller than 118, then don't do anything or whatever. So you can control this access. All right, and in most cases the accessors were good. Saw some funny business with mutators. A number of people tried to do something like this. right? So they tried to use this as a stand-in for the variable. Well, you can't do that. This is a method. This is not synonymous with secret tape, right? It's a method that returns the value of secret tape, but you can't use that on the left-hand side of an assignment statement. Just like you couldn't do that in C. You can't say square root of x equals 7, right? So that's why we make a separate mutator for setting. All right, so question 3, try-catch blocks. So mostly successful, but a few things to keep in mind. Number 1, keep your try-catch blocks as small as possible. A lot of people said try, blah, 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 catch, return -1. Right? That works. I gave you credit for it. I didn't say making them as small as possible. But always make your try-catch blocks as small as possible. Put them around the exact statement that can cause an error, or the exact 2 statements, or whatever the smallest block is that you can reasonably make. Integer sum equals 0, that's not going to cause an exception, right? It's just a declaration. This actually cannot cause an exception, because we're iterating up to the length of our array -1. And we're just adding these to an integer sum. So there's not going to be an exception that occurs here. Integer arg will not generate an exception. But anytime you see division by a variable, ask yourself, could that throw a divide by 0 error? And in this case, it could. It's possible the sum would turn out to be 0. So this is the statement that needs to be surrounded by a try block. So try arg equals 500 over sum, catch, return -1. And then outside of that, you can say return arg. You can do other things. You can put the whole thing in a try-catch, works perfectly. You could put this in a try statement along with a return arg. That works perfectly, right? But the goal is, readability and having the organization of the code match the intent of the program. So if we don't think that the return statement can throw an exception, why put it inside an exception handling block? Right? Put that stuff outside, and then the exception handling block just says, can we do this division? And if we succeed, then we're going to go ahead and continue with what comes after the catch part of the try-catch. All right, so some people did a try-catch around this, but did not do a try-catch around here. So that cost a few points. All right, and same thing in your catch statement. If you don't return a -1, you won't even compile, because the compiler will make sure you said average returns an int. It's going to insist that you have a return value in all possible cases. And if there's a path through here that simply exits without returning a value, it will complain at compile time. All right, question 4. So this was the more aggressive programming task. This was a complete program, and lots of details to get right in here. But basically, you're making a version of cat that only works with 2 arguments. So first argument is the source file to read. Second argument is a destination file to write. So a number of things that cost a few points here and there, some that cost more. So the first is, make sure you've got 2 arguments. If you're going to make a scanner out of args bracket 0, you got to know that you have an args bracket 0. Otherwise, you're going to get an exception, right? Make yourself a class named Java, named copy. So class copy, public static void main, Usual main program, beginning. So you want to make a scanner out of the first argument, and you want to make a print writer out of the second argument. Okay, so you need some imports. At least for scanner and print writer. Ideally, your imports are tactical, you know, java.io.scanner instead of java.io.star, and so on. All right, so that'll avoid any errors with trying to use an argument that doesn't exist. It also, you know, catches the case if you put more than two things on the command line. Yeah, you can use java.io.star. It just kind of increases the amount of overhead. You know, for a short program, you're not going to notice it. But in general, you want to make your includes as small as possible. Yeah, I mean, you could do java.star or star. But you know, it's like you could make one big include file in C that includes standard IO, standard lib, math, all of this stuff, and just include that, and it would probably work. But you're putting a lot more overhead on the compilation process. So, but I didn't take off for using larger imports than you needed. All right, so yay. So make sure you got your arguments, and if you do, then go ahead and construct your scanner. So your scanner construction has to go in a try-catch block, because if the file can't be opened for reading, you'll get an exception. So try. And if we're going to use a scanner, you got to declare it outside of your try-catch block. So scanner SC. SC equals new scanner, new file, args bracket 0. And I didn't say what to do if an error happened. I just said don't let it cause an exception. So you could just return here. You could print a message saying, you know, can't open file. I was fine with any of that. And same thing up here, right? If you don't have file specified, you could just return. You could print a message. It's up to you. Just don't fall through and let this thing throw an error message. Now, if you do this in the try-catch block, technically it would catch that exception, so I let you get away with that if you didn't explicitly check the number of arguments up front. And remember, you know, you could put the whole thing in a try-catch. Don't do that, right? That's not going to make you happy down the road. All right, so this will construct a scanner that we can read from, and we're also going to need a print writer. So we can set that up and then do another statement. Or, you know, you could do both of these inside one try block. I'm okay with that because you know, you're going to do these two things one right after another, and really if either of them fails, it's the same outcome. You're just going to exit. But, you know, I could print a different message here if I can't open the input file or whatever, so I'll just do a separate block. So we'll do a new print writer. And you can do this from the file name directly. So args bracket 1. And put a catch block to get out of there. All right, so once you've done this, what's happened, right? We're all set to read from SC and write to the print writer. All right, so a lot of getting tangled up at this point. But remember, we have, with scanners, this next line and next method. and they pair off with has next line and has next. And we have, next int and has next int and so on and so forth. Most often we can just read line by line, right? If we're just doing a direct file copy, that will work. If you use next, that will also work. But next line reads up to the new line, right, and gives you back that string without the new line on the end. So here's one way to loop this. So while the scanner has a next line, and you could do, string line equals sc.nextLine, and then pw.println line. All right, so that'll work. Got chat going on. All right. You could also, read one word at a time, but you would want to print with just a print instead of a print line. And reading a word at a time potentially loses, spacing information. So if, word 1, bunch of spaces, word 2, if I print this out like this, right, well, I need to put those spaces back in myself, and I don't know how many spaces I'm missing. So I could, print this out as line plus a space or something, but I may not get an exact replica of the file. And if these files have strange contents, that's not going to work very well. So you probably want to stick with line. But, here's another way you could do this. Right, and there's a nice one-liner. So go to the scanner object, call the next line method that returns a string, pass that as an argument to the print line method of the print writer. All right, so that's, very object oriented. So that works well. And then regardless of what you do, you've gotta close this at the end. If you don't close it and your program exits, your output may not actually get written to the file. Let's see. I think those are the main things in there. Some people use things other than print writers or scanners. They got into like, input streams or writers or things like that. And if what you did worked, then I gave you full credit for that also. But in most cases, people using those other things that we haven't talked about didn't use them quite right. For example, if you do write, you don't get a new line at the end automatically. So if you use next line and then you try to use a write method, right, you have to tack the new line on yourself and things like that. Let's see. Did the equal true for a while? I think it was because I knew as true returned a boolean. Yeah. So same thing here. Right? It works the same way. It's just more complex to read, and people who understand what the next line method does will see this and they'll immediately know what it does, right? Because it's a common construct. Whereas if you do this, then they have to read it. Or if you do well, has next line is not equal to false, which will also work perfectly fine, right? But again, it kind of forces you to think, okay, so this is going to be true and not false. Okay, so it's going to go on. Well, it's got a next line. So it's just, you know, things to keep in mind going forward. It's not going to break your code. For me, it's not going to cost you points. But it's fun to, you know, sort of build up our palette of ways of writing things, ways of doing things. Yeah, not equal to not equal to not true. All right, and then the short answer, true, false. So let's see. Current best practice is that Java classes should begin with an uppercase letter. That is true. I think everybody got that correct. So that's just current best practice. Class name Ginsburg should be placed in the file name Ginsburg. That is not true, right? If Ginsburg is the name of the class and it starts with an uppercase, the file should be uppercaseginsburg.com. Wow, I've got like radical amounts of incense smoke on the camera. There we go. So A is true, B is false. What command would you type to compile a file named sprinklefluid.java? So java c space sprinklefluid.java. And you need to specify the .java on the java c command. So I think everybody got that right. What would be the name of the class file created by compiling sprinklefluid.java? That would be sprinklefluid.class. And it has a .class extension so that the Java virtual machine knows it's a class file. But when we run it with Java, we just say Java space and we put in the name of the class without the .class part on it. But the class file still has a .class on it. What's the difference between int x and integer x? So I think most people got this, which was great. Int x is a primitive, right? Int is a primitive type. It's a built-in. It's one of the, I think, 7 types of built-in variables. And it's lighter weight than integer, which is actually defining a class. What is sprinkle fluid? 8-year-old daughter came up with that. So I was like, give me a funny noun. And that's what she came up with. So integer is, but I'll ask her what it is. I'll probably get a drawing of it if you want. So integer uppercase I, that's a class. So in this case, x is a full-blown object, and we can use it to access any of the methods or fields inside the integer class. Whereas x is a primitive, it's just a variable that can hold an integer value, but we can't invoke methods. We can't, you know, invoke the things that we can get to from a full class. What are the primitives? So integer, character, boolean, short, long. Who else? I'm sure there's at least 2 more. So there's 3 integers, short, long, integer. There's a character, there's a boolean. What are the other 2? We always skip them in 224 or 222. Float, there you go. And then what's the companion of float? Double, right. I don't know if there's an 8th one or not. I'm Googling. There's an 8th one. Oh, there we go, byte. I always forget byte. I feel bad for byte. So because characters are no longer bytes, right? They can be Unicode. So cool, we got all 8. Yeah, and bytes are like, you know, one of the first data types ever. I mean, long before floats and doubles and all that. All right, so that's primitive, and that's a declaration of an object. Long live byte. All right, do we need to worry about memory leaks in Java? So, technically no. All right, in the sense that, you know, we don't need to free objects when we're done using them. There's a garbage collector that will run periodically and will look and say, you know, here's an object that was created, but there's nothing referencing it anymore. There's no references to this. In C, that would be an inaccessible memory leak, right? There's no way to free it. In Java, the garbage collector just says, oh, you know, this thing is not being used, I'll reclaim it. And it grabs the memory and puts it back into the pool. Ooh. All right, so we don't really need to worry about memory leaks in Java. Consider the statement public rock int x. Is this a method or a constructor? So how do you know which this is? It's a constructor. Why is that? Not just the capitalization, because there's no return type. That's the real kicker. If we're following best practice, then we could say, yeah, this is going to be a constructor, because that's uppercase. That should be a class. But technically, it could be a method, even if it's named with an uppercase. But the fact that there's no return type specified, that tells you it's a constructor. And so when you write a constructor, you have to make sure you don't say, you know, public, you know, something rock. Because a constructor always returns an object of whatever type of thing you're constructing. So the return type here would be a rock, so we don't specify it. That's how the compiler knows it. Bitey sounds like what SpongeBob would name a pet bite. Like Wormy. Yeah, so if you decide to put a return type in here, it will still compile, but you don't have a constructor, right? And so you won't be able to use that as a constructor. Actually, I'm surprised it compiles with the constructor name. And yeah, so last 5 minutes of the exam, these can be a little strung out, inducing. Let's see, is the following a valid beginning of a main method declaration? Sure, absolutely. Public static void main string, haha. Best practice would be to call this args, you know, or something other than haha, but as far as being valid Java code, perfectly valid. A weird one to try to catch. That's a good Java pun also. How would you declare a variable named try-catch to be a linked list of strings? So here, playing with generics. So declaring a variable to be a linked list of strings. So linked list. And then it's generic, so we specify in angle brackets the type of thing that we want it to hold, and then the name of the variable. So that's the declaration. And then to construct it in part I, try catch equals new, and then the type of thing you want to construct, which for us is a linked list of strings, and then the argument lists to the constructor. And so technically this was the answer for I, this was the answer for J. If you put both of these on one line for I, you got credit. If you put them, you know, on one line for J, you got credit. If I saw those somewhere in there without something that was blatantly incorrect, I gave you credit for it. Let's see. And that was the only one that I was getting really nitty with syntax, right? Most of the code, you know, if you missed a semicolon or a curly bracket or something, as long as I could tell what you were trying to do, I didn't ding you on syntax, because that's what the compiler is for. But this one I wanted to see the placement of the angle brackets and the parentheses and all that kind of stuff. So only 1 month of physics. Wow, it's less than that. It's 4 weeks, so well, I guess that's close to a month. Yeah. So we're in week 7. And then Freedom, and then WSU. Someone posted a good what to expect at WSU in Discord. I think it's in the Segfault channel. It's pretty funny. Yeah, this has gone quickly, hasn't it? Term project and SLP done. Yeah, don't stress too much over the SLPs. I mean, if you've been working on it, just keep trying to work on it, for the next few weeks and write up your final report before the deadline. Submit that and come to the presentation. You can come back and visit a collaboratorium anytime you want, though. So that's always going to be there. Yes, essay on the social significance of cars too. All right. So any questions about the midterm? Yeah, definitely PA4 should be the biggest focus right now. SLP, I know this doesn't always work out like this, but the intent is, it's something you're kind of working on more or less steadily throughout, in this case, 2 quarters, normally 3 quarters. And when other classwork gets extra heavy, you kind of slack off on the SLP for a week, and when you've got a little bit of a lighter spot in physics and 223, you put a little more time in the SLP, and hopefully it works out, in the end. I know that's not always how things go. Sometimes it's like, oh, SLP is not due for 8 weeks, so I'm not going to worry about it this week, and then all of a sudden it's due in a week. But, do what you can with it. But yeah, definitely PA4 is more critical at this point. 1, because it's coming up. 2, because it is going to be a building block for PA5. And 3, because it's very object focused. It's a really good exercise for getting an even stronger notion of this idea of objects and classes and being object oriented and so on. They want a prototype in 3 days. Ooh. All right, how is PA4, speaking of? Draw line is working. Good, good. Going to start today, okay. Oh, cool. If you're up to initials, you're in really good shape, probably. So, initials. I don't think I mentioned this one, but I'm guessing you've already found it. So in the graphics class, along with draw line, there's a draw text method. Draw string. So you can say draw a string, give it a string in an XY location. So you can use that to put an initial in the middle of the box. Right? And if you know the coordinates of your box, right, if you know this coordinate and that coordinate, you just cut it in half, right? Take the average of the x's, that moves you halfway across. Take the average of the y's, puts you in the middle there. Or draw a bunch of small lines to make an initial. No. Lots of work. So let's see, figure out which side I'm closest to. So, let's say you clicked at some point XY. So figure out which box you're in, right? So divide X by box width, divide Y by box height, round down, right? Truncate, and that tells you which box you're in, and then, you know, take the box, multiply by height and width to find the coordinates of those four corners. So let's call these something. I'm going to give them horrible names. Right? Don't call them that if you're typing, you know, call it like X upper left, Y lower right, that kind of thing. But since we only have a minute, right? So now calculate your distance from each edge. So the distance to the left edge is going to be X minus X0. The distance to the right edge is going to be the X coordinate over here, X1 minus the X coordinate there, X. The distance to the top, well, Y is bigger, so this is going to be Y minus Y0. And the distance to the bottom is going to be Y1 minus Y. So calculate those four integers and see which one is smallest. So if this is smaller than that, and that, and that, then you're closest to the left edge. If this is smaller than that, or that, or that, then you're closest to the right edge. Right? So each of these numbers is your distance to a corresponding edge, left, right, top, bottom. Take whichever one is smaller. That's going to tell you which line you're closest to. And you can get fancy and put this in a loop and use arrays and that kind of stuff. You can also just write four big monolithic if statements. Nothing wrong with that. Right? So maybe put these into some variables so you don't have to keep typing them in because that's error prone. But, you know, I could call this like distance left, distance right, distance top, distance bottom. And then if distance left is less than distance top and distance left is less than distance bottom and distance left is less than distance right, then you're close to the left line. And set a flag to indicate that, right? And just write four statements. Yep, exactly. All right, so we are past time. So let's start talking about sockets tomorrow. So we'll start talking around about client-server paradigm and creating sockets in Java and how we interact with these. And so we'll be getting into networking, and that'll be fun stuff. All right, cool. Have a good one. I will see you next time.